This is problem number 4 from section 3.2. In this problem it says find the indicated derivative dy over dx if y equals negative 6x to the 3 halves. So we're going to start with dy over dx, and we're going to use the definition and say limit as h approaches 0 of f of x plus h minus f of x all over h. Now let's start plugging some stuff in, and we can say limit as h approaches 0. Plug in x plus h, we get negative 6 x plus h to the 3 halves. And then minus negative 6 x to the 3 halves, right? Just minus the function. And this is all over h. So let's go ahead and say that this is now limit as h approaches 0 of negative 6 x plus h to the 3 halves plus 6x to the 3 halves all over h. Now you have to recognize that although we have exponents here, these are radical exponents. So I think that the piece to unlocking this puzzle essentially is to multiply by the conjugate. We're going to multiply by negative 6 x plus h to the 3 halves, and we'll switch the sign and make that a negative 6x to the 3 halves over negative 6x plus h to the 3 halves minus 6x to the 3 halves. And now we're going to go ahead and multiply this on the inside. So we're going to get limit as h approaches 0. And when we multiply that, we take this times this term. That's going to be 36. And then x plus h to the 3 halves times x plus h to the 3 halves. Remember, when you have like bases, you add the power, so 3 halves and 3 halves is 6 halves, but that's just really 3. So it's x plus h to the 3rd. Multiply this term times this term here, and we're going to get positive 36 x plus h to the 3 halves, x to the 3 halves. And then multiply this term times this term, and we get negative 36. And that'll be x plus h to the 3 halves, x to the 3 halves. And then finally we multiply the last terms, and we end up with negative 36. And again, same base, x to the 3 halves and x to the 3 halves, so that's x to the 3rd. And we add them, because that's 6 halves, which is 3. That's all over h, negative 6, x plus h to the 3 halves, minus 6, x to the 3 halves. Now you can see the middles are going to cancel here. So this cancels with this, and we're left with limit as h approaches 0 of 36 x plus h cubed minus 36 x cubed all over h, negative 6 x plus h to the 3 halves minus 6x to the 3 halves. Now let's go ahead and take x plus h and cube it. And we've done this a couple of times, so this is really x plus h times x plus h times x plus h, and that gives you x squared plus 2xh plus h squared when you multiply the first two x plus h's. And then when you multiply each of these terms times each of these, you end up with x cubed plus 3x squared h plus 3xh squared plus h cubed. So let's go ahead and use this now down here. So we end up with limit as h approaches 0, 36 x cubed plus 3x squared h plus 3xh squared plus h cubed minus 36x cubed all over h negative 6 x plus h to the 3 halves minus 6x to the 3 halves. All right, let's go ahead and rewrite this up here, and we're going to say limit limit as h approaches 0, 36 x cubed plus, let's see, 3 times 36, that's 108, x squared h plus 108 108xh squared plus 36h cubed minus 36x cubed all over h negative 6 x plus h to the 3 halves minus 6x to the 3 halves. We can cancel the negative 36 x cubes, and let's factor an h out as well. So we end up with limit as h approaches 0 of h 108 x squared plus 108xh plus 36h squared all over h negative 6 x plus h to the 3 halves minus 6x to the 3 halves. The h's cancel, and now when I take the limit as h approaches 0 of what's left, I'll have 108 x squared plus 108 xh plus 36h squared all over negative 6 x plus h to the 3 halves minus 6x to the 3 halves. And you're going to see some stuff cancel. When I plug in 0 for h, that'll cancel here, and it cancels this part right there. So I end up with, I'm going to kind of draw a little line to separate these two things. What I end up with is, let's go equals, when I plug that in, I end up with 108 x squared over, I combine those together, that's going to give you negative 12 x to the 3 halves. 108 divided by negative 12 is negative 9, so I end up with not negative 9, I end up with, negative 9 x squared over x to the 3 halves. Now, I can bring this denominator to the top, so that's negative 9 x squared times x to the negative 3 halves when I bring it to the numerator. Now remember, we have like bases, we add the power. So what's 2 plus negative 3 halves? Well, this is 4 over 2 plus negative 3 over 2, which would just be x to the half. So I end up with negative 9 x to the 1/2. So my derivative is negative 9 root x.